lesson 11.5. We are talking about margin of error. Okay. Oh, forgot to mention, we are skipping a page in the notes. My apologies. Okay. So the next thing in your notes is 11.5, model and discuss. Yes, it's just one page long. I'm running out of days. I started stressing when I started counting how many days between now and the end of the semester. I'm very tight on days. So 11.5 model and discuss is an activity I like to sometimes do, but timing, it's not happening. Okay, if I have an extra day, I'll come back and do it, but I just don't really have that day right now. So we're gonna skip it, and we're gonna go into 11.5 notes. Okay. In 11.5 notes, we're talking about margin of error. Okay, so one of the examples we'll get to later on in the notes talks about someone claiming to be a 75% free throw shooter. Well, if you're claiming you're a 75% free throw shooter, does that mean you're always going to hit exactly 75% of your shots? No. Okay, 75% is more of kind of an on average thing, right? Some days you might hit more, some days you might hit less. So when we're talking about margin of error, it's, okay, what is an acceptable range? If you claim you're a 75% free throw shooter, but then you only hit 25%, are you really a 75% free throw shooter? Because 25% is really low. Okay, so looking at margin of error, okay, that's where this lesson is headed. Now, before we get there, we're going to talk a little bit about populations and samples again, and look at this example with, I think it starts off with Seth. Eventually we add Tia later on. So we're going to talk about estimating a population parameter here. So Seth selects a random sample of students from a local college. He asks students their year in college and how far their college is from their home in miles. Okay, so we're looking at Seth's data chart here. So each student he asked, so like for instance, the first student is a sophomore and lives college is 5 miles from home. The next student is a junior and college is 50 miles from home. Then you've got a freshman, college is 65 miles from home, so on and so forth, right? Okay, so that's what you're looking at there. Now, as you look at this data, some questions to ponder. How can Seth's sample estimate the proportion of freshmen in the population? So keeping in mind, did Seth survey every single college student? No. Seth has a sample here, yes? This is a sample of the college students from the local college, and this sample is supposed to represent everybody. It represents the population. Remembering sample is the smaller piece, and a sample is a piece of the bigger population. How can his sample estimate the proportion of freshmen actually in the population? What are you thinking, Ian?
Take the whole number of what everyone being sampled, and then you divide that by the number of freshmen to the next.
Okay. So can we look at the proportion of freshmen in Seth's sample? And if this is a distant sample, what's the idea? That sample should represent the population. So the idea that the statistic we find here for the sample, that will represent the population. Okay, so we are actually going to find it. But how can his sample? Well, we can find the proportion of freshmen in the sample, and that's an estimate of the population. And then we'll actually find it here in a moment. Or did you guys already find it?
20%.
What do we know? What do you have to figure out here? How many freshmen? How many freshmen are we looking at? I wasn't agreeing or disagreeing until I counted, because I couldn't remember for sure. Okay, so 4 freshmen. What else do we know? Okay, count up. How many people did he survey? He did survey 20. Okay, so it's going to be 4 out of 20. Now, So I'm going to go back and answer the first question first. How can his sample estimate the freshmen in the population? I'm going to say find the proportion of freshmen in the sample as an estimate of the population. Okay. So the whole point of having a sample is you can use that to find approximations here. We agreed that there were 4 freshmen out of 20 students surveyed. What other ways can we express 4 out of 20? What was it? Okay, 4 out of 20 reduces to be 1/5. So we can say 1/5 of the sample is freshmen. What else? Okay, 20%. What else? 0.20 or 0.2. Okay. Technically, I would have gone from 1/5 to 0.2 to 20%, but those are all ways it can be represented. Yes. I don't know what Savas, I don't remember if Savas asked for this in any situation, but, all ways to talk about the proportion of freshmen. Now, are we saying that there are exactly 20% freshmen at this local college? No. We're saying there are 20% freshmen in this sample, and if this sample is a good representative, then there are approximately 20% at the college. Okay? Now, how accurate is this estimate likely to be? And it's not even that we're really going to answer how accurate it's likely to be, but what are some factors that would determine how accurate it is? Okay. And as you say that, the amount of students that go to the college, kind of in comparison to what? What did Seth use? Yeah. Seth used 20 students, right? What about 20 students? Okay. Well, yeah, we can come back and talk about, how random, were they chosen. But 20 students, I don't know what size college this is. It just says local college. Say there's a couple thousand students at this college. Is 20 going to be an accurate estimate for a couple thousand students? It could be, but is it guaranteed to be? No. What would we say about a sample size? I mean, if I'm just looking at a population of 100, is 20 a decent size? Yeah, probably. What about 20 out of a couple thousand students? That's really kind of a small, That's like saying, okay, we're just going to survey this class of, what do we have, 12 students out of the whole school. Is that really a very, that's a very small portion. Okay, so what I'm trying to get to here is that the larger the sample size, the more accurate that sample is going to be, representing the population. Okay. And then Michaela started talking about how random is it. Okay. We don't have any information about where he got his students from, do we? Is it like the one girl that surveyed her friends in her gym class? Or, is this a more diverse population than that? Okay, do you see what I'm saying there? So the more random, the better. Okay, or what I would look at is just, in general, the better the sample represents the entire population, the more accurate it's going to be. Okay, now, he seems to have a pretty good diversity, doesn't he? So I'm not saying it's bad in that case, but the more random, the better, right? Don't go sit in a freshman class and survey everyone around you. Okay, or I shouldn't even say freshman level class, but a typical, well, freshman level. That doesn't mean only freshmen are taking it. Okay, like even a high school class. Okay, so am I making some sense here? Okay, so those are the two key factors I have written down. Talking about sample size and, you know, what type of sample it is. So I'm going to write some information about those, but the first one is the larger the sample size, the more accurate the estimate will be. The larger the sample, the more accurate the population will be.
More accurate.
The larger the sample, the more accurate the population will be, or the more accurate the, I should say estimate. Is that what I should say? Yeah, that should say estimate. That would make more sense, wouldn't it?
Is accurate a word?
Not to my knowledge. It's more accurate.
I'll just put that. But I can't.
I think that would be bad grammar. The larger the sample, the more accurate the estimate. Sorry guys, struggle bus. Is that better?
Yeah.
Okay. And I just in general, the better the sample represents the population, the more accurate the estimate will be. That's the other piece I have here. The better the sample represents the population, the more accurate the estimate will be. Okay. So larger sample size, more accurate the estimate, the better the sample represents the population, the more accurate it will be. Okay. Got your calculators ready? Use the sample data to estimate the mean distance from home. What are we estimating? The mean distance from home. So we're looking for the mean.
How are you 2 miles away from me?
Could you live 2 miles from IUK?
Yeah.
I mean, there's people that live across the street from IUK, so.
It's just weird though. Like, bro, if I'm going to college, I don't know. I'm going like far away.
So you're going to be the 800-mile away person.
Yeah, I'm going.
To each their own, right?
Yeah.
Some people want that. Some people like, take me over to the West Coast. Take me to California. Take me to Hawaii. Other people say, no, I'll go with IUK. I'll go with Ball State. I'll go with Purdue. I'll go, keep me in Indiana.
I don't know, I'll go
To each their own.
I'll go anywhere.
Okay, what are we finding for this mean?
100.85.
Because?
Because 2017 divided by 20 equals 100.85.
Okay. So 2017 came from adding all the numbers up. Don't hit a wrong button, right? And then there were how many values? We talked about 20 earlier. So you're dividing by 20. Calculator says 100.85. What's my label?
Miles.
Miles, because it's a mean distance.
Yeah, right. A kid that was born in 2017 is 8-year-old.
Okay, continuing on. Final question this particular section. Ask us to estimate the proportion of seniors to the total population at the college. What do you know? Do we agree? So, there's 3 seniors. Is 3 my answer? No. Okay. 3 seniors out of the sample size of 20. What do we know about ways to express 3 out of 20?
15%.
Okay. It is a decimal of 0.15. It is a percent of 15%. Okay. Okay. You're kind of getting into this problem, right? Because we're not leaving Seth yet. Now we're going to add Tia to the problem. This is a multiple part problem. We talk about Seth and Tia a lot today. Okay? Okay. As I said, we're going to add Tia on. So Tia is contributing to the same project as Seth and has sampled a different group of students. The proportion of her freshmen in her sample is 0.40 or 40%. How can Seth and Tia determine whose result is a better representation of the population? Because what do we know? They just told us Tia's was 40%. What did we come up with for Seth and freshmen? That was 20%. That's kind of different. You know, I think of 20% close to a quarter and 40% of close to half. That's kind of different. Thoughts? How can they determine whose result is better? We don't have the information to do Z-score.
The sample, the percentage of the sample, like freshman, sophomore, junior, and senior will be lower than targeted restricted on the better side. Percentages for each grade will be lower.
Right, but how does it help me to determine whose result is a better representation?
Because it's more evenly distributed.
Because what?
It's more evenly distributed.
But do we know that it's more even? Do we know that this college has an equal representation of freshmen, sophomores, juniors, seniors? I mean, we want to assume that, but I don't think we know that, do we? Okay. If anything, I would think there might be more freshmen than there are sophomores, juniors, and seniors. But just because you have more people start out, then you have more than people that finish.
Yeah, people drop out.
So now, here's the deal, guys. Not looking at the data of what we have here. We have Seth's numbers, we have Tia's numbers. What if we go with the idea of we need more? How could that help us? Could we look at more samples? What if we have more samples? What if we have more sets of 20 students?
Yeah.
How's that going to help me?
It would provide a different
And I'm not just talking of like one more, but I'm talking of, say, instead of just having, right now we have 2 samples, what if we had 20 samples?
It would provide,
I mean, yeah. Can we then look at, okay, what, what's the percentage of freshmen in each class? Or in each sample, sorry. Okay. So that's a big thing right here, is that, one, looking at more samples. So, okay, we've got 2 samples to look at. What if we get 20 more samples, 50 more samples, 100 samples? Or, these samples are only 20 students. We already talked, 20 students isn't a very big sample if we're talking a college, right? Even your small colleges, that's not a very big sample. So what's another option? Could we maybe each have them sample, say, 100 students? Get a larger sample size? Okay. So those are the 2 thoughts that I want you guys thinking about, is that they could look at more samples, or they can look at larger samples. Either way, what are we trying to do? We're trying to get more information, right? We're trying to talk to more people, find out more results. And that's all I'm putting on this one, is just writing that information down, is that Seth and Tia can I'm going to say examine more samples or get larger samples. Okay, so key things there, more samples or larger samples, or both. I guess I just noticed in my notes I have and/or, so. Okay, get what you need there. Look at the next page. Realize Seth and T aren't going away yet. We're just adding on to this problem. They do go away eventually. Then we talk about Alex and Gabriella, so for several pieces of the problem. Okay, so we had Seth's sample. We had Tia's sample. Now, guess what? Everyone in Seth and Tia's class completed the same survey. So everyone in there had a sample of 20 students. The histogram shows the results of the 50 total samples of 20 college students each. So they're saying there's 50 people in their class, and all 50 people surveyed 20 people each. Now we're getting some more data. Now we're talking to more students, and that's the whole point here. Okay, so now the question isn't really specifically stated here, but now we're still kind of back to that question of whose is better, Seth or Tia. Okay. Now, before I go there, what do you notice about this shape? Does that shape look familiar? Yeah. This is that idea of the normal distribution curve. Is it exact? No, but it's that idea, right? Is that you've got more data in the middle, less on the ends. Okay, so it is that shape of that normal distribution curve. Now, if you start thinking about, what do we know? Seth had what? 20%? Which I believe the way they have this set up is that his 20% would be represented in this 0.15 to 0.2 bar. What was Tia's? Tia's was 40%. So hers would be represented in that 0.35 to 0.4 bar. What's that make you think? Seth's was more accurate, maybe? Does it go along with more of the data? It does. Okay? And I just drew those lines in there trying to get you guys to think about, okay, where are their results in relation to everybody else? The one thing that I can talk about, you will, in this lesson, this book talks a lot about, okay, where is the majority of the data? And they use the number 95% of the data. So if we look at where is the majority of the data, notice if we take off the two little n's, the majority of the data is falling in that 0.1 to 0.35 range. And if the majority of that data is falling in that 0.1 to 0.35 range, 0.2 falls in that range, doesn't it? 0.4, while close, it falls slightly outside of that range. Okay? And when there's already a bulk of data there, that leads you to believe, okay, we're going to be looking more in the 20% here for an accurate answer. Okay? So, things I'm going to write down. This is an approximately normal distribution. Most responses fall between that 0.1 to 0.35. So it is reasonable to predict the proportion of freshmen to be between 0.1 and 0.35. That means Seth's result is a better representation than Tia's. Okay? So that's information I'm writing down. Approximately normal distribution is the first thing I'm going to write down, just to remind you of the shape. And you guys know what I always say, write as little or as much down as you want. I would encourage you to write something down. And then most responses fall between 0.1 to 0.35. So reasonable to predict the proportion of freshmen in that range, or how do I want to write that? Most responses fall between 0.1 and 0.35. So reasonable to expect, I'm just going to say freshman proportion in this range.
What if they asked the same?
Well, I know Seth and Tia specifically said that they didn't. We're going to assume that there's definitely some variety. Could there be some overlap? It doesn't indicate one or the other, but at the point when you've got 50 different students doing the same survey, there's got to be a decent variety there, is what you would expect. Okay? And so we're going to say that Seth's result is the better representation. Okay, so key points that I would encourage you to get down on your paper. Okay. Let me know if you can't read something. This is where my handwriting gets sloppy when there's a lot of it. Trying to go fast. Fast is not good for my handwriting, though. Probably not good for most people's handwriting, but. Okay. Still talking about Seth and Tia a little bit longer. Each classmate calculated the mean distance home in miles reported by their participants. So remember, we did that on Seth earlier, right? Seth and Tia created then this histogram to investigate the statistics. So here, you have the results of the 50 samples. So you have 0 to 25, 26 to 50, all the way up to 126 to 150 as their mean distance from home. And this is how many of how many samples fell into each of those categories. Okay. Now, first question. How many of the samples reported an average distance from home between 101 and 125 miles? Are we afraid to guess? It is kind of a guessing game. I'm not going to argue there.
6.
Do we like his guess? 101 to 125 is which bar? It's that bar right there, yes. Definitely between 4 and 8. I agree with 6. If you're slightly off one way or the other, it is what it is. But I think it does, if you look at this bar on the right to be down here at 4, and then 8 being that next line up, I would say that there are 6 samples that reported their average to come out between 101 and 125. Okay. So 6 samples have average distance of 101 to 125 miles. Now, it asks us, 6 samples fell in the 101 to 125 range. What did ours on the front page from Seth was what? 100.85? 100.85 would technically fall in that range as well, wouldn't it? Okay. Or that is one of them in that range, I guess I should say. Now we want to ask, use this histogram to suggest a reasonable interval to estimate the population parameter. So if we're using this data and we want to say that most students live this far away. Now, what I'm going to caution you of, we're not going to narrow it down too far. Okay? This is an average distance, and keep in mind, the highest average here goes up to 150. Didn't we have someone that was 800 miles away on Seth's list? So this is just an average. But with that in mind, they like to go for this 95% of the data thing. Okay? We're looking at 95% of the data. Okay? You're looking at pretty much the middle chunk of it, taking off a little bit on either end. If we look at that, where is our middle chunk of data here? And again, we're trying to be symmetric about it, because does this kind of have a normal curve to it? Not exactly. I mean, it's going to be a little lopsided, but it does to an extent. Okay. When we start looking at that middle chunk, the middle chunk I'm looking at here, if I ignore basically the two ends, is looking from there to there. So I'm looking from what? 26 to 125. Which really, that's only a 100-mile distance, isn't it? And when you're talking about people that are 2 miles from campus to people that are 800 miles from home, that's not bad to narrow it down to 100 miles there. Okay, so average distance from home is likely to fall between 26 and 125 miles. I'm going to say average distance likely to fall, what do we say? 26 to 125 miles. Okay? And you'll see this trend. The more we continue in this lesson, you'll see this trend of the middle 95%. Okay? It will keep occurring. Okay. We'll spend a lot of time talking about Seth and Tia today. Spend most of our time talking about Seth and Tia. We're going to spend just a couple minutes. I'm going to introduce Alex and Gabriella. And then we'll do the math with it tomorrow. Okay. I mentioned this scenario at the beginning of class. This is Alex, and he claims that he is a 75% free throw shooter. Okay, so Gabriella wants proof of Alex's claim that he is a 75% free throw shooter.
She's calling him out on that.
She is. She observes Alex shoot 53 throws, of which he makes 30. Gabriella notes his 60% success rate. But Alex points out that this is a reasonable result due to the natural variability that happens from sample to sample. Is he correct? So basically, the overall question we're going to look at, if he's claiming he's a 75% free throw shooter, could he have a day where he makes only 60% and still be a 75% free throw shooter? Or is Gabby saying, that number's a little low. I don't really think you're a 75% free throw shooter. Okay? So Alex is saying, okay, so it was an off day. I shot, I didn't make as many as normal. Whereas Gabriella is saying, no, I just don't think you're a 75% free throw shooter. Now, which is right? Okay? I mean, other than looking at data over a long period of time, we don't have hardcore data to look at this, do we? Okay, if this is just a random claim, if this is just, as he's practicing and stuff, I don't necessarily have data to look at. So we're going to talk about ways we can use random number generators. Okay, your calculator can do a random number generator where you can ask it to, okay, give me a number between 1 and 10. And you can keep going through it, and it keeps giving you numbers between 1 and 10. Okay. Excel could do this. Okay, and I should use a bigger goal like 1 in 100. Excel could do this. You can set up Excel to say, okay, give me a number between 1 and 100. And you can have it keep repeating, just like you could a calculator.
Okay, it's not effects and right above the
Well, I think that's just saying formula there, but so. Okay, so now, as we look at this real quick, where am I at? Well, we'll talk about it more tomorrow, but notice there's numbers 1 to 100. Do you notice the two colors? Blue and orange. What about the blue numbers?
The blue is over 75.
The blue numbers are the numbers that are over 75. So what are the oranges?
No.
That's the 1 through 75. Keep in mind, he claims he's 75% free throw shooter. So 1 through 75 represents that he made it. 76 through 100 are going to represent numbers that he didn't make it. Okay, so that's basically saying, okay, I get a number of 50. Ooh, that's 1 through 75. That represents a make. Number 76 through 100 represents a miss. So we'll look at this data tomorrow and dig into it.